Here's a solution for day 4, problem 1. Butch is reducing a digital photograph on his computer. The original photo is 21 centimeters by 16 centimeters. If he reduces the dimensions by scale factor 50%, what would be the perimeter and area of the new image? And so I'm going to draw a quick sketch of this just to help me visualize what's going on. Here is a rectangular shaped photograph. It is 21 centimeters tall and 16 centimeters wide. And we're going to transform this. In geometry class, you learned that the symbol for transformation is an arrow. And what's happening is it's being reduced, so made smaller, by scale factor 50%. And so on my transformation arrow, I can show that multiplication by a scale factor of 50%. We can think of 50% in terms of a decimal, that's 0.5, or as a fraction, that's a half. Either way. So what's going on here is we want to multiply these original dimensions by a scale factor of 50% or a half. We want to find half of these. So 16 times a half is 8 centimeters, and 21 times a half is 10.5 centimeters. With these new dimensions, we can find the perimeter and area. So let's find perimeter first. To find the perimeter of a rectangle, the formula is twice the length plus twice the width. And so 2 times 10.5 plus 2 times 8. Well, 2 times 10.5, remember that was 21, and 2 times 8, that was 16. So 21 plus 16 is 37 centimeters. It is 37 centimeters around the outside of this photograph. Okay, now the area. Area of a rectangle is length times width. And so 10.5 multiplied by 8. 10 times 8 is 80. Half times 8 is 4, and 80 plus 4 is 84. A little bit of distributive property there to help me multiply the mixed number times 8. So 84 square centimeters is the area of that photograph. Day 4, problem 2, we have these 4 arithmetic problems. So question A, negative 54 plus 12, a negative number plus a positive number. We end up having to find the difference between the numbers, or think of subtracting these numbers. And the 54 is the larger number, and it's a negative number. So when we find the difference between them, we're going to have a negative value remaining. 54 subtract 12 is 42, so negative 42. Question B, 21. Subtracting a negative could be rewritten as adding a positive. 21 plus 21 is 42. Okay, question C, we want to add these mixed numbers together. So 3 2/5 plus 2.5. We can add the whole numbers together, 3 plus 2, and get 5. To add the fractional pieces together, we need to have common denominators. So we could multiply this by 2 and by 2, and this one here we could multiply by 5 and by 5. Again, I'm already taking care of the whole numbers, I'm just worrying about the fractional pieces now. So this makes 4 tenths, this makes 5 tenths, adding together that's 9 tenths. 5 and 9 tenths. Question D, multiply these fractions together. 3/4 times 28 over 21. We could multiply straight across, and then simplify the final answer. But if we can do some simplifying ahead of time, that will make it easier in the long run. So 3 and 21, these reduce. 3 divides by 3, leaving 1. 21 divides by 3, leaving 7. 4 and 28, we could reduce those. 4 divides by 4, leaving 1. 28 divides by 4, leaving 7. We could multiply right now and then reduce, or notice that there's even more reducing that can take place. 7 divides by 7 once, and 7 divides by 7 once. Hey, when we get done doing all of this reducing, some people call this cross-canceling, notice that multiplying everything together, we just get an answer of 1.